Hello friends, welcome to the platform of IQCIVILS Academy. These are the government projects, myself Narendra Sharma, and these are the panel of elite faculties which you can see here. And these are the government projects by IQCIVILS IAS Academy. This is the Google review, and through this, now you can see that what kind of reputation IQCIVILS IAS Academy has built up in Assam, isn't it? So these are the panel of elite faculties and these are the inquiries regarding admissions. So you can contact on these numbers for any query, any kind of questions, isn't it? Which is related with your admissions here. The next batch is going to start in 20th November. Okay, 20th November. And today we are going to discuss, don't forget this date, that is 20th November. Okay, for the inquiries, you can call on these numbers. See you. Today we are going to discuss a topic which is known as mechanism of precipitation. So today's topic is mechanism of precipitation. Let's see what is the general mechanism for the precipitation in anywhere or any part of the world. So first of all, for the starting of precipitation, we need moisture. Okay, so moisture from water bodies, oceans, or sea. So there must be huge water body, or what you can say, a huge sea or the ocean through which abundant of moisture can comes in the atmosphere. And mechanism of precipitation generally occurs in summer because the hotness leads to increase in the temperature of the ocean, and because of that evaporation starts. So because of this heat, evaporation starts and moisture comes in the, you can say, moisture comes in the lower atmosphere. Okay, now this lower atmosphere is filled by the moisture, and as you can see, this is summer. So during summer, due to sunlight, convectional current, through convectional current, the heat is transferring itself from the lower atmosphere to higher atmosphere. But here, the gases which are hotter, they're also responsible for collecting moisture. So the sample of air, this is a sample of air in which you can have such amount of moisture as you can see inside this sample. So moisture is there. Why? Because the warm air mass can hold more moisture. And why warm air mass? Because this is summer. In summer, warm air mass is holding moisture and starts uplifting. So moisture laden winds starts uplifting in the upper atmosphere. Okay, See, if the heat is more, the volume of the air mass will be more. If the heat is less, temperature is less, the volume will also be less. So if temperature is high, it means you can add more moisture in this volume of air. So if temperature is high, humidity is also high. Here temperature is less, that's why volume of the air mass is less, and that's why less amount of moisture can enter inside it. So humidity is less. It means temperature is directly proportional to humidity. ठीक है, टेम्परेचर ज़्यादा मतलब मॉइस्चर भी ज़्यादा. So temperature is directly proportional to humidity. Temperature is less, humidity is less. Now see, this is convectional current, and through this convectional currents, warm air mass is rising in the upper atmosphere. But this warm air mass, when it is reaching here, obviously the volume is contracting because in the upper atmosphere, temperature decreases. So as the warm air mass is rising in the upper atmosphere where temperature is less, and right now what we can see, not only the temperature is less, but you can see the moisture content. Moisture content is, I mean, see, the holding capacity is, here holding capacity is less. Why? Because the temperature is less, so air mass has contracted. But the same amount of moisture which was present here, isn't it? The same amount of moisture is also present here. But here you can feel the density is high. Density of moisture is high. Why is it so? Because the air mass has contracted. You can see the volume of this air mass is lesser than this air mass. Where the volume is less, that's why the same amount of moisture is looking what? More, I mean, in quantity. But here, the quantity of moisture is same as it was here. Just because of contraction of air mass, isn't it? Contraction of air mass, the moisture is looking very what? It is looking very dense, isn't it? But it's not so. Next. So due to continuous rising of warm air mass in the upper atmosphere, the sample is also going to contract. Contract means the air mass is also going to contract, and the moisture will be, now you can see, and you, it seems that much of the moisture contains in this volume of air mass. But exactly what is happening, whatever the air mass, whatever the air mass, ballpoint highlighter, whatever the air mass, uh, here the volume of the air mass is higher in this part, but moisture is less. And as we are going higher in the atmosphere here, the volume is contracting because of less temperature in the upper atmosphere. तो यहाँ ठंडा है टेम्परेचर, तो एयर मास का भी वॉल्यूम क्या हो गया, कम हो गया. एंड मॉइस्चर वाज इन सेम क्वांटिटी, लेकिन यहाँ पर मॉइस्चर क्या दिख रहा है, हियर यू कैन सी द मॉइस्चर इज मोर इन क्वांटिटी. It is exactly the same amount of moisture which was here and the same amount of moisture which was here. But just because the volume of the air mass has decreased, the moisture content seems to be more in quantity, but it is not exactly same amount of moisture is transferring in the upper atmosphere. Just because volume is becoming less, इसलिए वो ज़्यादा दिख रहा है. Now when the warm air mass reaches here and the sample of air mass has highly contracted due to very less temperature, and now it is filled by complete what? It is filled by, it is not filled completely. Basically, the same amount of moisture is also here. Whatever the amount of moisture which was here in this area, The same amount of moisture is also here. But just because volume has contracted due to less temperature in upper atmosphere, ऊपर के एटमॉस्फेयर में टेम्परेचर क्या होता है, कम होता है, तो वो कॉन्ट्रैक्ट करता है, एयर मास इज कॉन्ट्रैक्टिंग, तो एयर मास का साइज क्या हो गया, कम हो गया, एयर मास का साइज कम हो गया, तो उतना ही जो मॉइस्चर है वो ज्यादा दिख रहा है. दिस इज, here the air mass is completely filled, so what we can say, RH. RH is 100%, relative humidity is 100% here. Here the relative humidity was 75%. Here the relative humidity was 50%. And here the RH was, or relative humidity was 25%. So in this air mass, RH is 100%. It means no any extra moisture. I mean, any extra moisture is not going to add here. Okay. So not even a single drop of moisture can be added. Why? Because of what? Because of not any single drop of moisture has been added, because the space has not been left. So this is, RH is 100%. In this condition, the air mass is known as saturated air mass. Saturated air mass means when the RH is 100%. Now no more moisture can be added here. Okay. So now it is ready to condense. It is ready to condense. This air mass is ready to condense. Condensation can occur, but the condensation does not occur directly. See, obviously the air mass has been saturated. Sufficient amount of moisture is available in the upper atmosphere for the condensation or the formation of clouds. But still, when RH is 100%, air mass is completely saturated, but maybe cloud formation won't start. Why? Because it means if cloud formation has not started, it means still the vapor pressure is required, isn't it? So in order to increase the vapor pressure, we need to have hygroscopic nuclei in the atmosphere. What are they? They are known as hygroscopic nuclei. So they are hygroscopic nuclei. What are they? Hygroscopic nuclei means water loving nuclei. Isn't it? They are basically the pollutants. Let me erase some of the things so that. So hygroscopic nuclei, you can see these hygroscopic nuclei are ionized. So there is a plus and minus charges. So plus is here, minus is here, again plus, again minus, again plus, again minus. So these hygroscopic nuclei are basically, they are pollutants of the, they are pollutants of what? Pollutants of atmosphere. For the longer duration, when such pollutants are suspending in the sky, they become ionized. Now these hygroscopic nuclei which are ionized, they are attracting the moisture from the saturated air mass because they are also ionized. So saturated 100% saturated air mass was also ionized. So opposite charges attract. So suppose plus of saturated air mass attracted to minus of hygroscopic nuclei. Isn't it? And minus of saturated air mass attracted to plus of hygroscopic nuclei. In this way, the molecules or the saturated air mass, the vapors of saturated air mass are sitting over the The moisture is sitting over the hygroscopic nuclei. And when they are sitting over the hygroscopic nuclei, what is increasing? Vapor pressure is increasing. Mind it. Okay. So vapor pressure is increasing, and vapor pressure is increasing means what? Vapor pressure is necessary for the vapor pressure is necessary for what? So vapor pressure is necessary for the condensation. So here condensation occurs because of hygroscopic nuclei. Okay, and clouds formation has started. So clouds formation has started, or if clouds has been formed, it means condensation has occurred. Okay, so this is condensation. Condensation means what? Condensation means formation of clouds. So you can see here, cloud has been formed. Okay, clouds has been formed. It means condensation has occurred. Got it? And now see, the temperature at which saturation was occurred. Here क्या हुआ था? यहाँ पे क्या हुआ था? Saturation हो गया था एयर मास. 100% saturation. Temperature at which saturation has occurred is known as dew point. Mind it, dew point, DW. So for the condensation to occur, the dew point must be between 1 to 3 degree. 1 degree to 3 degree of temperature for the condensation to for to achieve the condensation. 1 से 3 डिग्री के बीच में टेम्परेचर होना चाहिए. If the temperature is more than suppose 3 degree, that is 4 degree, 5 degree, whatever, then obviously condensation won't occur. Why? Because the saturated air mass becomes unsaturated. ठीक है, क्योंकि टेम्परेचर बढ़ जाएगा तो क्या होगा? इस एयर मास का क्या वॉल्यूम फिर ज़्यादा हो जाएगा, और वॉल्यूम ज़्यादा हो जाएगा तो उसके अंदर का जो मॉइस्चर है वो कम, ऑटोमेटिकली कम हो जाएगा. तो इस केस में, इन दिस केस, द एयर मास इज नो लॉन्गर सैचुरेटेड. And if the air mass is no longer saturated, it means this air mass, I mean non-saturated air mass, is not going to condense. So for condensation to occur, the RH should be 100%, and condensation RH 100% होगा, लेकिन condensation तब होता है जब ड्यू पॉइंट क्या होता है? ड्यू पॉइंट इज बिटवीन 1 to 3 डिग्री. तब क्या होगा? ये कंडेंसेशन होगा. इफ ड्यू पॉइंट इज मोर देन 3 डिग्री तो वो डीसैचुरेट कर जाएगा, एंड ड्यूरिंग डीसैचुरेशन ऑब्वियसली कंडेंसेशन नहीं होगा. तो सैचुरेशन होने के बाद भी इतना सैचुरेशन कितना टेम्परेचर पे होगा? लगभग 1 to 3 डिग्री. इफ द टेम्परेचर ऑफ द एयर मास हियर इन द अपर एटमोस्फेयर is less than 0 degree, okay, then this air mass is not going to this air mass is not going to condense, but it will freeze, that if the temperature is 0 or less than 0. So if it will freeze, then obviously precipitating clouds won't form. The clouds will have ice crystals. इसके अंदर क्या होगा? Ice crystals develop हो जाता है. Okay, so see here, this cloud, whatever the cloud is, what? Cloud is a form of condensation. So how cloud has been developed? When the saturated air mass finds what? Hygroscopic nuclei. And hygroscopic nuclei has increased what? Vapor pressure. Okay, vapor pressure. And if vapor pressure has increased, then condensation will occur. Vapor pressure means, suppose you have seen when you are making something, or when you are suppose making tea, isn't it? The vapors from the tea is going to condense was the object, some kind of object. नीचे से क्या होता है, कोई ना कोई ऑब्जेक्ट होता है, और वहां जाकर वो टी क्या करेगा, हिट करता है टी का वेपर्स. सपोज तुमने प्लेट रख दिया, इफ यू आर पुटिंग द प्लेट्स ओवर द टी, vapors of the tea are going to, they will touch the plate, and after touching it will condense. Okay, for the condensation to occur, हमें कोई ना कोई, what we need, some kind of surface is required. That surface will increases what, it increases vapor pressure, and vapor pressure is highly required in order to, get what, condensation. So condensation के लिए क्या क्या condition होना चाहिए, mind it, for the condensation or the formation of the cloud. The condition is like, first of all, RH should be 100%, isn't it? I mean, the air mass must be filled completely. Then dew point must be between 1 degree to 3 degree. Okay, and there must be presence of hygroscopic nuclei, so that required vapor pressure can generate. So these are the conditions for the condensation or formation of clouds. Mind it. So these are the conditions which are required for the condensation. Okay. So when such conditions are achieved in the atmosphere where sample of air mass is present with sufficient moisture, okay, then condensation occurs. But until and unless vapor pressure is not generating, condensation is not going to start. If condensation occurs because of hygroscopic nuclei, so hygroscopic nuclei are providing what? Surface for the condensation. So hygroscopic nuclei provides surface for the condensation. In this way, clouds form. Condensation हो गया मतलब क्या हो गया? Clouds form हो गया. And within the clouds, first of all, cloud drops are forming. Mind it. Cloud drops are the bigger drops. Okay. And when the drops becomings bigger and bigger, then the clouds will become heavier and it will start falling downward. Okay. So it will start falling downward. Let's see. So clouds, suppose it becomes heavier, then cloud drops will fall like that from the cloud. And after that, due to friction in the atmosphere, they will be smaller in size. And smaller size, now they are not cloud drops, they are known as raindrops. Okay. And the same raindrop, when it touches the surface, it is finally touching the surface in the form of what? Rainfall. Rainfall, first of all, what has happened? Cloud drops have been formed, then raindrops has been formed, and then rainfall occurs. And this rainfall is going to mix up in the ocean again, and from the ocean, due to evaporation, again the moisture comes in the atmosphere, which completes circle, a cycle which is known as hydrological cycle. Okay. Now tell me, what are the, I mean, through this mechanism, what are the steps? The first step is, in context of mechanism of precipitation, the first step is insolation. So insolation is required means heat is required. In order to what? You can see here the sun is heating the what? Ocean. So heat is required in order to what? In order to convert water molecules into vapor. Or this much heat is required for the evaporation. So first step is insolation. Second mechanism in the mechanism of precipitation. The second step will be evaporation. Okay, second step is evaporation. Now, what is the third step? Let's see. Third step is after evaporation, when moisture comes in the atmosphere. Okay, you can see moisture comes in the atmosphere, and that moisture is now it is holded by sample of warm sample of air mass or sample of warm air mass. Okay, so after evaporation, what is happening? The warm air is, you can see in this diagram, warm air is rising higher, ascending higher in the atmosphere. So warm air mass is rising higher in the atmosphere in the form of convectional current. Okay, so here you can write third step of the mechanism of precipitation is third step is a rising of air mass, rising of air mass with moisture, as you can see in the diagram. Okay, this is the third step of mechanism of precipitation, which you can see here. These are the convectional currents which are rising higher in the atmosphere. Okay, so this is the third step. Fourth step is when the air mass is rising at a sufficient height, that is more than 1 kilometer above, then the air mass will saturate. So the next stage is saturated air mass. Saturated air mass. Okay, so insolation, evaporation, rising of air mass with moisture, and then saturated air mass. Okay, so this is about fourth step where air mass has been saturated, and the temperature at which air mass is saturating is known as dew point. Okay, now see. So this is your uh, these are the steps which are involved in the mechanism of precipitation. Next one is the next step is condensation. But without hygroscopic nuclei, condensation won't occur. Next step is availability of hygroscopic nuclei. Okay, and then condensation will start. So condensation begins when hygroscopic nuclei, as you can see in this diagram. So hygroscopic nuclei are doing what? They are increasing vapor pressure, and vapor pressure is required for the condensation. Then clouds will form. So clouds condensation means cloud formation. And then cloud drops are forming, as you can see in the diagram. Cloud drops. Okay, these cloud drops are bigger in size. That's why they are falling on the surface due to gravity. Cloud drops are nothing but the pieces of smaller pieces of the clouds, which are bigger in size. And due to friction in the atmosphere, the size of the cloud drops reduces into raindrops. Raindrops. And this raindrops finally it comes on the surface. The raindrops finally comes on the surface in the form of rainfall, and this rainfall is going to mix up the ocean again, and hydrological cycle completes. So, my dear friends, this is all about mechanism of precipitation. Here, the relative humidity, here the RH is 100%, as you can see here. RH is 100% means here the moisture is 100%, which is relatively higher than the previous sample of air mass where moisture was 75%. So it is basically the same amount of moisture is transferring from here to here, same amount of moisture. But as the size of the air mass is decreasing because of decrease in temperature, same amount of moisture is looking higher here 100%. तो ये 100% दिख रहा है क्योंकि साइज एयर मास का कम हो गया है तो पूरा सैंपल भरा हुआ दिखाई दे रहा है. But basically this 100% air mass, isn't it? This 100% air mass, 100% saturated air mass is having same amount of moisture which is present here, same amount of moisture which was present here, and the same amount of which was present here. But suppose in this stage, the air mass size of the sample of the air mass is bigger because of high temperature in the lower atmosphere. That's why the same amount of moisture is also here. But यहाँ क्या दिख रहा है थोड़ा खाली दिखाई दे रहा है. यहाँ खाली क्यों दिखाई दे रहा है? यहाँ साइज बड़ा है इसका एयर मास का, क्यों टेम्परेचर ज़्यादा है. देखो इफ टेम्परेचर इज हाइयर RH is lesser, that is 25%. यहाँ जाके टेम्परेचर और थोड़ा कम होता है ऊपर. सपोज here I'm writing temperature is suppose 35 degree. So suppose temperature is 35 degree and RH is 25%. Here temperature is suppose 25 degree and RH is 50%. Here the temperature at this height of the atmosphere temperature is 10 degree and RH is 75%. And here suppose temperature is 2 degree but RH is 100%. So it means temperature is inversely proportional to RH or relative humidity. Okay, in the higher atmosphere temperature is lesser, so RH is higher. हायर होता जाएगा और एक टाइम के बाद इतना हाई हो जाएगा कि लगेगा कि पूरा सैंपल जो है वो पानी से मॉइस्चर से भर गया है उतना ही मॉइस्चर जितना नीचे था, पर यहाँ पर एयर मास का साइज छोटा हो गया जस्ट बिकॉज द साइज ऑफ द एयर मास बिकम स्मॉलर. दैट्स वाई ऐसा दिख रहा है कि इसमें मॉइस्चर पूरा फिल्ड हो गया है. ओके, so my dear friends, this is all about mechanism of precipitation. We'll meet in next video, but don't forget to get admission in new batches which are going to start from 20th November. And for any kind of inquiries regarding admissions, you can contact on these numbers. Our YouTube channel link is such and such. And these are the elite panel of faculties from Delhi, as you can see. These are the what we can superstar of their subjects. Okay. If you want to get the benefit of these faculties which are coming from Delhi in IQCIVILS IAS Academy, obviously you need to do what? You need to get admission here. So I mean don't make don't be late, isn't it? If you want to get your selection in 2023, okay, then you must join this institute. All the best and thank you. Okay.